So ln problems, which we never went over in class, but had a ton of on homework. The derivative of ln, or rather ln x, because you don't have ln without the others. The derivative of ln x is just 1 over x. That is something you can remember. It never changes. If it's just ln x, it's 1 over x. Okay? So, the problem it gave me was this. ln of 2x, and then it gives me the point. So, ln of 2x at 6 and 2.48. Okay? So, you're going to find the derivative and then input your x value. So, f of x is ln of 2x. And then you take your derivative of that. Well, the derivative of that is just going to be, you're going to do x prime over x in this case. Okay? So your x is going to be 2x. And your x prime is going to be the derivative of that, which is just 2. So obviously those are going to cancel out, and you're going to have 1 over x. So if it is just a number and an x after the ln, if it's just ln of 4x or ln of 700x, it would be the same concept. You would say 4x on the bottom or 700x on the bottom over the derivative. Those are going to cancel out, and you're still going to be left with 1 over x. 1 over x. Every single time. And so then in this case, it gave us this point. Obviously, our y value is not necessary there. We just have to plug in our x value. So 1 over 6. And that would have been our answer. 1 over 6. And that was, in fact, the answer. 1 over 6. Okay, so we're going to move on to some that weren't necessarily part of the homework. Some of them were, some of them weren't. But they'll help you to solve some of the ln problems. So I'm going to write several. So ln of x squared, ln of x cubed, ln of x plus 5, ln of x squared plus 4, ln of negative x3 plus 7x plus 5. And that's what we'll start with for now, because I believe the others that I have on my paper should be things that we get questions for. So in this case, you can't quite do the same thing for these because of the exponent. You can't just put x over or x prime over x. It doesn't quite work for all of them. It only works for some of them. So we're going to do it the way that should work for all of them. So in this case, you would do 2 times ln x, because you'd move your exponent to the front and subtract 1. Actually, in this case, you don't even have to subtract 1 for this rule. It's kind of weird that it doesn't have that for your, it's not something you have to do. Same thing for this one. This one would be 3 ln x, which these then equal out into 2 times, remember I said ln x is just 1 over x, and so then you'd have 2 over x. Same thing for this. You'd end up with 3 times the derivative of this, which is just 1 over x, and that would just be 3 over x. So if you just have ln and then x to an exponent, it's just going to be whatever the exponent is over x. Okay? In this case, you do have to find your 2 things because you don't just have ln over x or ln x, and you can't take the 5 away from the x to create that sort of problem. So in this case, you do find your x and your x prime. So your x is the whole thing and your x prime is just the derivative. So your x, which is going to go on the bottom, is x plus 5. The derivative of x plus 5, remember there is an understood 1 here and here. 1 times 1 is just 1, and our exponent and our variable would drop away. And so would our whole number. So we would just be left with 1 over x plus 5. And that's the end of that one. I'm going to erase some of this to give me some more room. All right. So this ln of x squared plus 4. Same thing as before. Bottom, derivative is top. Okay? So our bottom is going to be x squared plus 4, and our derivative is going to take our exponent times whatever our constant there is. So 2 times 1 is 2. 2 minus 1 is still 1, so our exponent would stay. Or not our exponent, our variable. And so then we would be left with 2x over x squared plus 4, and that's as far as it would want us to go. Same thing here. You do your whole thing on the bottom and your derivative on the top. So 3 times a negative 1 is a negative 3. X squared, because 3 minus 1 is 2, plus a 7. And that would be what they would want from us. Yeah, that's all they need. All right, so I'm going to stop this video here and then continue on with our homework questions. Hopefully that helps solve the LN questions just in case there's any on the practice test or the actual test.